Hello and welcome to a little quick video, a little extra to the regular Raspberry Pi solar panel powered weather station set of videos. I'm doing this now because I might not get time to put that in any of the main videos. Anyway, I want to cast your mind back to the first part one of the first of the videos that we were doing on the Raspberry Pi powered solar weather station. You will recall that I bought some solar panels like these, or these are the solar panels that I bought, just in shot for a bit, just so I can explain that. You will remember, and if not, I'll show you that there was in a pop-up window in the video, but there was these voltage regulators that were on the back of the solar panels, and these came directly from the panels to an output, which was a USB output right there. Let's just see if that's all in focus. I don't even know if this is in focus at the moment. Let me just try fix that. Yeah. So these were on the back of the solar panels, and they were in this horrible resin glue, but I managed to take them off without breaking them too much, although I have ripped the contacts off this one. Now, if you recall from the actual video, I thought that these were suspect voltage regulators that were on the back of the solar panel, because they kept switching on and switching off. And again, I'll show you that in a little picture-in-picture display on the video. But yeah, so I thought that there might be something wrong with these, and just to give you a background of what a voltage regulator does, a voltage regulator will try and keep an output voltage constant depending on the input voltage. Now, there's two ways it can do this. It can actually have a reference voltage and always try and maintain the output voltage with regards to that reference to the same voltage, or it can constantly monitor the output and the input and try and like a feedback loop to try and regulate the voltage. But these two I took off and bought another one because I thought these weren't working very well. What they were doing is they were just switching on and then giving a 5 volts out and then switching off again. No matter how much sunlight I put on the solar panels, these never seemed to work correctly. So I thought what I would do today, with the aid of a bench power supply, and that's just in shot here, you can see it here, is to try and test these and see if they do actually work, or if they my assumption was correct and they were in fact broken. So let me start by getting some voltage on these things here then. So first off, I've got my solar panel. I have got my solar panels, but I've also got a multimeter. And the reason why is that the voltage meter on the bench power supply doesn't seem to be working particularly great, because the graduation isn't great, and it also seems to, even when there's no voltage on it, I don't know whether I can show you this. Yeah. Well, there's no voltage on it at the moment. It's not at zero. It's still halfway on the meter, which is a bit strange. So I'd expect when there's no power going to it, that it would in fact be at zero, but apparently that's not the case. And so what I've done is I've set the output voltage to the lowest possible reading, and I've set the switch to voltage output. I'm going to put the multimeter on something like 20 volts. Okay, I'll put this in shot so that you can actually see a display. It's got a light on it. Is that the light? Yeah. Let me put that down actually, because you'll be better to see it that way. So I'll put it there. Don't know whether the light's better or if it's just swamping the camera. Yeah, it's probably better without the light, so I'll leave that off. Now, apparently it's on 5 volts, which is interesting because I've got the bench power supply turned down to its lowest Let me just have a check to see what it says it's going to give out. Yeah, so it says it's going to give out 5 volts variable, so it'll go from 5 volts. So 5 volts it is. We're starting with 5 volts. Now, if 5 volts are coming from the power supply, one would expect that if I was to plug in one of these voltage regulators, that all would be fine, because these voltage regulators are set, the component values are set to put 5 volts out of the USB socket here. So one would suspect that if there's 5 volts going in and 5 volts coming out, it would have, the electronics would have no problem in regulating that supply and making it constant 5 volts, one would assume. So let's try that out. We know it's 5 volts here, but it's 5.12 volts coming out of the bench power supply, and that's DC. Okay, I'm just going to switch that off. I'm just going to take this. I've got an adapter which has crocodile clips on, so I'll be able to monitor this. Okay, and I'm going to uncouple that from the bench power supply and couple that up to there. And then I'm going to do the same with the positive from the bench power supply and couple that up to here. So you see what's happening here is that I'm going to put in underneath the let me just see if that's syncing. That's, yeah. So underneath the voltage regulator, there's a positive and negative, or positive and ground. I'm going to put that input to this will be the voltage regulator, will be the power supply, which is taking the place of the solar panel. And then whatever comes out of the voltage regulator, I will be monitoring using the multimeter. So again, I'll put that on 20 volts. So it should be 0, and it is 0 because there's nothing in there. So the blue light indicates that it's working, but then it's gone off. And if you can see the display, we're getting 5 volts out. So we're getting exactly near as damn it what we're putting in out at the peak when it's on. 5.12, we've been putting 5.12 in, and we're getting 5.11 out. But it just seems to cycle. So even with a constant 5 volt voltage going in, it cannot cope and restarts itself. And this the feature of restarting itself, resetting itself, is by design. If it can't maintain that current, if it can't maintain the voltage, but it should be maintaining the voltage at that level. So what I'm going to do, so that's at 5.12 volts going in, it's regulated, and as I'm getting out 5.12 there? Yeah, pretty much, yeah, 1.12. So I'm getting out what I'm putting in. It's still cycling all the time, which is very strange. So I'm going to try and up this output of the bench power supply somewhat, see what we get in there. I've moved that up. So that's a constant 5. So now we're getting 5.2 volts out, so one would presume about 5.2 volts in. And I'll measure it again after this to see what we in. But it's still cycling. There's no way this would ever produce a constant output enough to power the Raspberry Pi. So I'm going to up it again. What are we on now? Yeah, it's 5.26 now. And it's still recycling. So even at 5 volts and above, it can't make that a constant supply. So I'm going to put it up. I'm going to put it up to a little bit more. So it's still on 5.26. But it's staying static now. So I don't, until I put the multimeter back onto the output of the power supply, I'm not going to know what's going in, but it still doesn't seem to be. Let me just have a quick look and see if I can find out from the dial on the front. Yeah. Okay, so we do appear to have a sort of impasse here. The voltage regulator that were on both of the voltage regulators that were on the back of the solar panels do appear to be faulty. I'll just take this off here, and I'll just take this off here, and uncouple the crocodile clips from the other end. Put that on the ground just to see what we're actually getting at this level. There you go. So it was putting out 5.26, so it was doing its voltage regulation fine. I was putting 12 volts in at the end of that test. So we started off with 5, just over 5.12, and by the end I was putting in 12.43. And in terms of regulation, it was regulating the voltage quite well. It was putting out, it went from 5.1 at the start right the way up to 5.26. That's not a huge distance. It's still around the 5 volts. Even though I was putting 12.43 volts in at the input. So what we come from that conclusion is that even though the power supply was putting out anything from 5 volts to 12 volts or 12.5 volts at the end, going into the voltage regulator, the voltage regulator was actually functioning as its core role. So it was regulating voltage, because even if 5.12 volts going in, it was 5.12 volts going out. But when 12.5 volts were going in, 12.4 volts going in, it was still regulating it to 5.26 volts coming out. And that, as regulation, is pretty good. It's trying to maintain the constant voltage, and that is working. What doesn't appear to be working with these voltage regulators, and I suspect they'll be the same on both of them. I will test the other one out, but this is going to be harder to do because I need to put, and this one, the contacts have gone. But I'll try this out, and if I find the same results on this one, I'll post them in the description. But yeah, so the bit that doesn't work on these voltage regulators is the extra functionality to try and restart or shut down and recycle the power if it suspects that the voltage is dropping below 5 volts, because clearly even at 12 volts that it still was recycling, but the output was a constant 5 volts, so that bit was working. But either way, completely unusable, because I can't put a Raspberry Pi on these, because if it's going to cycle every minute or 30 seconds, entirely useless. So both of these are entirely useless. However, I have bought another one, and that on early tests seems to be working fine, because it doesn't have the bit in that cycles if it suggests that the voltage is dropping too low. So it is on early tests. This new voltage regulator seems to be working fine. Anyway, that is all from me for now. Stay tuned for part 3, and when I record it and film it and test it and do other things, so you'll be interested in it. Like and subscribe, press the dingy bell, because that's how YouTube works, and I'll see you next time.